Good evening, everyone, and yeah, welcome to another JavaScript in London with myself and Pawel from PricingMonkey, obviously hosted by Oliver Bernard. Yeah, another week in lockdown has gone by. Hope you're all keeping safe and healthy. Not much else to say, really. I think my internet's a little bit patchy, so I'm going to pass you over to Pawel pretty quickly. But please do put your questions in the chat functionality. Pawel will be giving his presentation and then answering those as best he can at the end. And obviously, anyone who is in a situation at the minute where they want to discuss anything to do with the job market, recruitment, or just the chat in general, feel free to reach out to myself or any of the team at Oliver Bernard. But yeah, I'll now pass you over to Pawel, and I'll speak to you all again at the end.
Hi there. Can people hear me? This is first time I'm doing it online, and I just want to make sure.
Yes,
Yeah, awesome. All right. this is really interesting for me. Pawel Badens, and my co-founder and the CTO at PricingMonkey. We're a fintech startup, and we do a fancy, complicated thing of building a platform for pricing financial derivatives. And I'll stop it there. And technical bits. Yes, I wanted to talk to you about our experience of the past 4 years, the journey of trying to do this performance-heavy web application and do it in JavaScript and in the web browser as well, which has been quite a journey. I'm originally actually from Java development. For you who some of you may have seen the bio that was on the website. So I have a few years ago moved on to that JavaScript and continued my my journey in performance engineering. That's all obvious. I sort of might bring a bit of nerdy references to Java, for which I apologize. What this talk is about. I'm going to talk about performance, but I'm also going to talk about good design. I think those two things are very related, and one kind of works with the other, and one requires the other. And if you want to build high performance, you really need to build design and good quality architecture. That also means that I'm going to talk both about choosing the right technology, so all the technical details of high performance, but also I'm going to try to talk about choosing the right architecture. So for people who are looking for me talking about the technical details and all the bits that we discover journey that, I will probably stuff a little bit too much. So a lot of it is going to be more of a start of it for you to explore further rather than a complete picture. But to talk about good design, good quality design, and how you can fit that into your own constraints, your own so-called cross-functional requirements, evolving high quality design. So none of this what we did happened overnight, and we didn't have a huge big upfront plan on how to do it. We made lots of mistakes, we learned from them, and we evolved further. Also, I'm doing this talk first time in this setup, so just it's very new to me and feels a bit odd. I'm also doing this talk for the first time, so apologies if some things are not quite there. I hope this will be as very useful as useful for you as the journey of learning these things was for me. And please do keep asking questions on the chat. I will try to answer them as they're coming. a bit more about the context. I feel it's very important for me to mention the setup for this. I think that when I go to conferences, when I go to talks, it's really easy to sort of get out from the talk with this idea, oh, this is cool technology, we should use it, and sometimes forget about it's all in the particular context of the application it was designed for, and it's the same for us. So what I will be talking here is what kind of problems we had and how we solved them, and it's really important for me to mention that it's for you to sort of fit it into your projects, into your requirements. So this sounds really obvious, but I think it's really easy sometimes to jump to the solutions, jump to solving things before really knowing the problem, and most importantly, I think accepting your problem. I think at the beginning of my journey as a junior programmer, I think the challenge is more on the knowing. You learn through your journey, you learn how to understand the setup better, understand what are you building against, what is the business requirements, what is the non-functional requirements. And then as you learn more, as you become more senior, I think it's about accepting the problem. So sometimes you might not like the answer, you might not like the fact that the solution is WordPress or lots of CRUD pages, but that's what it is. And this kind of reminds me a bit like 5 stages of grief, where it starts with denial and hopefully ends with acceptance. And I think it's often for me happened that in my journey, it kind of didn't go farther than the denial stage, and I ended up building something that was not quite there. So what is the context for us? Our context was a CPU bounded application in the browser. So what does that mean? I remember a few years ago when we had a really good expert performance engineer coming onto the project, and they've been using this term CPU bounded, and I was really baffled by it. And I was like, well, what is that? Like, how can they use it? So they kept saying CPU bounded, memory bounded. And it took me quite a while to understand that CPU bounded is really a term for saying, if you get more CPU, your program will run faster. So you might have memory problems, and if you get more memory, your program will run faster. Very important to understand what gets. If you're trying to, it's very important to know what's stopping you to getting better performance. Is it network? Is it memory? And these things can change as well. So in our case, it's almost always entirely CPU, but there are some problems when you add a bit of CPU and suddenly the memory is the problem. So it's very important to know your context, at every stage of the evolution here. For us, it was low CPU in the browser, more specifically in Chrome. We mostly target Chrome. Now, in numbers, that would be anything between 500 to 1,000 Redux actions per second. If you're not very familiar with Redux, that would be, imagine events, imagine messages being processed by some type of logic, and you're processing anything in the order of magnitude of hundreds of messages per second, which is actually, I can tell you, quite a lot. And in terms of financial computations, it's around 100, or if you like, 10 to 2 order of magnitude. So hundreds of computations per second, which each computation taking up to 50 milliseconds. So those computations are actually dependent on live market data, live data that's changing. So you might need 5 seconds to calculate everything, and then you have to start again and again and again. So if you put it in the browser, you can basically imagine 5 seconds crunching, and then I got another 5 seconds, other 5 seconds. So if we just put it in JavaScript, you'd basically load the page and not even display anything, not even ask for user input. You would just keep crunching data. just to kind of help you imagine that our UI is sort of like a spreadsheet in the browser. So there's a lot of columns which represent financial types of financial computations, and there's a lot of rows to represent financial instruments. And once you kind of see that this is a spreadsheet, you will see that, you know, you have each cell kind of requiring a separate computation, and suddenly you have hundreds and upwards of hundreds computations to process. Technologies kind of standard in these days, I believe, React, Redux, and a little extra, RxJS. I will talk a bit more about what Reactive.js, RxJS is later. And you know, your mileage may vary, but something important to mention: high performance. That the domain, that requirement, constraint that we had, that from my experience, almost always, or always, I would dare to say, comes at increased complexity cost. And that's sort of, I think oftentimes people say, yeah, your clients, your business experts say, if you ask them, do you want it fast? They're like, yeah, I want it fast. I want it as fast as possible. Whereas really, the deal here is, you know, how much are you willing to pay for it, both in money terms, but also in complexity terms, because again, you will need better design to support your performance. You will need to evolve better design to support your performance. You will need to accept essential complexity of the of higher performance. And for us, that was our context. That was our problem. So what followed is, you know, the requirements in design and the consequences in complexity. A bit on performance in general. Quoting Kent Beck, which is known as one of the fathers of TDD, test-driven development, but also amazing programmer, and especially very inspiring when it comes to talks about software design. So I strongly recommend, if you have not seen or heard Kent Beck, do Google him. He said, make it work, make it right, make it fast. So this is a really cool thing to say, but kind of like, you know, what does it mean? What is it that we really should get from this? So my interpretation of this is, first of all, if your code isn't working, there's no point optimizing it. Now, I had this professor in the university who made a very nerdy joke, and he would ask this question: what algorithm is the fastest algorithm there? The fastest algorithm is the one that does nothing. Second step, make it right. Simple and readable code is the one to optimize easier. So if you just kind of start optimizing immediately, you're setting yourself for a more difficult journey. So once you make sure that it works, that you does what do you think it should, and by the way, I strongly recommend looking into unit testing that code. Seems to be obvious these days, but unit testing this code, or even test driving your code to make sure it does what you think it does, but also to facilitate change. One of those change would be making it right. Another type of change, refactoring, would be to make it faster. And simple and readable code is easier to optimize for you, but also what many people, many of you probably know, it's also easier to optimize by the computer. So I'll give an example of V8. V8 is an engine that runs JavaScript in Google Chrome. V8 has something called optimizing compiler. And what it does, it takes the code takes JavaScript that you give it, and then on the fly, it tries to apply heuristics, it tries to apply smart rules to make it run faster. And if your code is simple, you will make easier job for V8 to optimize it. So just to give you a quick example, short methods. Short methods generally are easier to optimize by optimizing compiler. And there's many of these rules. Short methods would be one, making sure that your objects look similar when you pass them to methods, and so on and so forth. And it sort of reminds me again of Java. Like I said, I'm originally a Java programmer, so I will doing a bit of references. In Java, the recommendation for writing performance code was write simple code and write obvious code, because that's the easier code generally to optimize by the computer, and make it fast. Now, two things before you make it fast. First of all, make sure that the algorithm you're optimizing actually matters, right? So if you're optimizing, if you're making something 100 times faster, but it takes 1% of your overall code, okay, fine, you just made something 100 times faster of 1% of the total time. Literally, you won't be able to notice that. Second of all, and that's probably one of the fundamental things that I still keep forgetting, I still keep catching myself making mistakes after many, many, many years doing performance engineering, is always measure before and after. So it's a lot of time that this has happened to me when something looked really obvious. Oh, I can just make this faster. I can just optimize it. And then I measure it. I'm like, no noticeable change. And then you notice, oh, because actually there's been this caveat. Oh, there's been this problem. So this has happened to me, to my friends, to my colleagues, in my experience so many times. And it's one of the main reasons I say, for me, saying performance engineering is hard. It's hard because it's really not obvious most of the time. Okay, so now getting on to these two stories that I wanted to tell, which I think are pretty common when it comes to performance stories. So this is in our context. So again, it's kind of, for you to map it out to your context. Our two stories was one, overworked main thread, and second one was managing asynchronous calls. So starting with the first one. That probably majority of you already know that, but just to kind of be on the same page, when you include script in your HTML, when you include JavaScript on your website, when this code runs, it will all run in the same thread. So all the code that you have in your included JavaScript will run sequentially. Now with caveats, right? Like, how is it that this JavaScript code can do so many things at the same time? HTTP calls and keyboard clicks and keyboard presses and mouse clicks and mouse moves and all those events. It does it because it has this thing called non-blocking IO, which basically makes sure that if you have asynchronous actions, you can actually have an illusion of running many things at the same time. So that's sort of actually how iPhone used to work back in the days. Now, more and more today, we are stuffing more things onto our JavaScript applications, and they actually require CPU time. They actually have to run, proper code, so to say. So, you have to process collections, you have to filter things, you have to run those for loops, you have to execute those business logic rules. All this requires CPU time. And suddenly, all this runs in your single JavaScript package on a single thread sequentially, and the user is experiencing slowness. Their mouse moves slower, the clicks take longer, because it all runs in the same thread. So if you hog the CPU, your browser tab will eventually freeze. And I just want to make sure, emphasize that JavaScript is fast. I think nowadays, I'm actually very impressed the journey it took. I think there's two reasons people think JavaScript is is slow. I think one is history, because it actually used to be kind of slow. It's getting so much better every year. But second one, I think, is because we still haven't, as JavaScript community, we transformed very quickly into these rich applications, and we still haven't quite embraced how to manage that in a Node.js environment that wasn't initially actually designed to handle so much happening in one thread. And if you want to hear more about that, and there's a really amazing talk, I believe from last year, by one of the Google employees that details this very in a very specific detail, called "The Main Thread is Overworked and Underpaid." By the way, I totally stole an idea of overworked thread from that person. If you're familiar with this, this is a JavaScript profiler output. If you're not familiar, have a look. Google JavaScript Profiler, check it out. It's really interesting. It helps you understand what's happening in your application in terms of performance and usage of GPU, CPU, rendering, and all sorts of performance aspects. In this case, we're looking actually at the snapshot of our website loading, and the yellow bar that you see that's taking the whole space is actually the UI thread taking 100% of CPU time, working hard to render the application. That's what the overworked main thread looks like. Now, financial computations are by nature CPU intensive. There are a lot of mathematics, there are a lot of loops, there's a lot of collections, transformation. That's the context we're in. And for us, because of business constraint, we need to run some of these calculations in the browser. So on user's PC, we need to, in real time, based on real market changes, we need to calculate, relatively complex financial computations and make sure that the user can still use that PC. So obviously can't block the UI. Not only we need to, crunch those numbers, but we need to be able to render them. We need to be able to take the input from the user, and so on and so forth. So solution, right? Get off the main thread. If it's so overworked, outsource the work to somewhere else. And what do you call these in JavaScript? Web workers. So for people who were wondering what those web workers are, they're basically as secondary threads that can help out your UI thread with all the lots of work that it's doing. A quick example of what implementing web workers look like. We first of all need to load the web worker from a separate JavaScript source file. So like I was mentioning, when you load your JavaScript files in HTML page, they will be all loaded for the UI thread. And if you want something in the web worker, in the separate thread, you have to load it from a totally separate JavaScript file. That's going to be important. I'm going to mention a little more about this later. And then you need to establish a communication channel. So you'll be sending messages to your web worker. This is how web workers communicate, is a message-driven design. And you're going to be receiving messages back. So in this example, you send a message to your square.js. You send a number, and that number gets squared. You calculate, in this example, 5 to the power of 2. You get it back. And when you get it back, you print it out using console log. And when you do that, you'll get 25. So what is it about web workers? Some of these things I've already mentioned. They communicate via messages. That's something that probably could use another talk, but kind of quickly mentioning it. There's two ways of designing this sort of threaded communication in Java. Again, I'm sorry, Java developer. For example, you can actually share the context between threads more easily. They can share common memory. And JavaScript, it's actually, some might say, a cleaner way. You can you need to get a data structure, send that data structure to the web worker, process it, and send a message back. So if you've heard about actors or message-driven architectures, that's what it is. It's actually very similar to how your microservices work. But in microservices, you use HTTP to send messages, HTTP messages. Here, you'll be sending messages as JSON or as JavaScript objects. So there's no memory sharing. I think this is something to embrace. And as the more you learn about web workers, the more you understand the sort of how much constraints this creates. For example, you can't get one function from your UI thread and use it in a web worker. Those will be separate functions. And you have a Redux-based application, and you need to keep state updated. You'll have to send the whole state each time to your web worker. There's no other way. You have to make sure that these things get synced. You can't share these. Web worker is loaded from a separate JavaScript file, which means that you'll need to package your JavaScript code process with its dependencies and put it into separate bundle and load a separate bundle. So there might be some considerations there. Amazing stuff. Recommend something we've been using for almost since the beginning of the project now for Webpack. The worker loader basically makes it very transparent for you. Using web worker is very transparent for you. So our code is in TypeScript, and so what happens is we just have all the code nicely, modularized, imports everything, and it's the Webpack. What Webpack does, it looks for our web workers, creates all the dependencies, packages the bundle the same way it would package the bundle for the main UI thread, and wires the code so that it works when it's all bundled together and delivered in the browser, and you don't have to worry about it all. Yeah, so a bit of a history lesson. So I'm not trying to be, I just want to emphasize, I'm not trying to be snarky. Just to kind of mention context that, every language has to go through its, through the steps of its own evolution. So JavaScript initially and Node.js initially was targeted at non-blocking IO and asynchronous problems. And then when it became really successful, it sort of moved on to solving CPU-based problems, became CPU-bounded, you might say. And now we're trying to solve these problems. So one thing, for example, there is you actually might look to Java and learn some lessons of what they did right, or basically not repeat the same mistakes. So some caveats. Something that we still experience. So our platform has been built a few years ago, and we do sort of refresh every now and then. But I think it seems to me that it's still my experience that web workers feels very bare metal. So there's worker loader that I just mentioned, but other than that, I find myself seeing that library support. People don't think about web workers. I have personally filed many issues with various popular libraries or did pull requests for this and other library, for this and that library to support web workers. So as a kind of example is Prometheus metrics, for example, out of the box does not support does not support web workers. So basically, if you choose to use web workers, remember that there's this thing that I mentioned. There's this complexity that comes with them. So there's a bit of learning that comes with them. There's a bit of work where you'll have to build your own libraries and your own patterns and your own practices. There's no really good messaging framework. What you've seen on the previous slide, that's what it is. And if you, there's some solutions that replicate, there's some solutions from Google that has developed that sort of help. So you might find some solutions, but from my experience, has been very limited support. If you're familiar with Akka, so there's nothing like that out of the box to be used. Again, we have spent some time learning these and building this, and I know this is a bit of a lack there. Marshalling and marshalling. So basically, marshalling and unmarshalling, again, fancy names, basically for saying turning your JavaScript object into a data structure that you can send over the wire. So that might be a string, or that might be a series of bytes in more raw form. And then unmarshalling, so taking your series of bytes or a string and putting it back to a data structure that's represented in memory. So that's a fancy word for marshalling, and unmarshalling is a fancy word for that. So sending web worker data to the UI, it has varying support. It's not awesome. I certainly know of at least one case. There's an open issue, actually I think at the moment closed issue on ImmutableJS, asking for marshalling and unmarshalling support, which basically ends with, this is not supported by JavaScript at the moment. And that still hasn't changed. So this is possible. It's just something that you'll have to figure out, and it's something that you'll have to build yourself. Again, controversial. Java has this solved, in my opinion, slightly better through the interfaces that tell how to marshal and unmarshal objects. Something that's been very important for us, like for priority queuing. If you're not familiar with priority queuing, basically imagine you offloaded information onto a web worker, task processing onto web worker, you send 1,000 tasks to that web worker, and now user clicked on an important button, and you have 1,000 tasks waiting to be processed, but you need to process this one task very quickly. What you need is priority queuing. You basically need a way to say, hey, this task is really important, I need to process it right now. So that's not there. A very shameless plug, we have actually built a very thin layer, borrowing from jests, borrowing from other people's solutions a bit. We combined it together and built something that basically provides that in an efficient way. I think making it efficient took us a few tweaks. Last but not least, something that was a dark spot for us and really difficult. So as every performance heavy, as you know, in your applications, monitoring is everything. Right now, observability being a big thing, and making sure that you know what's happening in production, happening for your users, using Prometheus, using Grafana, those tools. Unfortunately, you can't track memory usage in the web worker threads. That hopefully will change in Chrome 84. There's a new solution coming, which you can, the slides will be available later, so you can check the link there to understand more of what's coming in terms of memory tracking in Chrome later this year. So what did we learn from this? We learned that JavaScript can take a lot. JavaScript is a fast language, and it certainly is becoming faster than it's been when we were using it 3 years ago. I still remember when we were waiting for async await to be introduced 4 years ago. Nowadays, pretty good. So I want to debunk that. Contrary to popular opinion, pretty fast. A lot of JavaScript is optimized by optimizing compiler, A lot of it is compiled to C. It's very similar to what Java has been doing to that journey. We're doing that. We're doing that for financial, for fintech domain. I'm certainly sure it can be done. Like, as I mentioned on the previous caveats slide, at least 6 reasons why there's no free lunch here. And you really need to weigh the complexity versus gain when it comes to incorporating web workers. Sort of Zen Zen comment here, but everything comes at a cost. And something that I believe that web workers are becoming microservices of the browser. So we're really going a direction where people are looking, and Google is looking certainly, and React is looking how to incorporate the more complicated, the more complex, the more powerful our applications and websites are becoming. We're looking how to offload that to one more web workers, and web workers are sort of becoming the microservices of the browser. And if you're looking at using them, I would certainly recommend checking out this article from the 90s. History kind of comes back to remind about itself again, written by Robert C. Martin, also known by Uncle Bob, to help you understand how you can structure your application if you choose to use web workers. And the structure actually is very similar how you do with microservices. So you would, separate them as separate modules. You would establish clear interfaces and so on and so forth. Okay, so that's to story number 2. If there's any questions about web workers and these sort of considerations, please please add them on chat. But there's also going to be a time at the end to discuss this. Okay, story number 2, a bit about managing asynchronous calls. So in an application like ours, we have a lot of things going on, and a lot of things happen asynchronously. And I'm pretty sure that sort of resonates with people. In JavaScript, in Node.js, lots of things happen in asynchronous way. And making sure that this is organized well and is performant, and you can sort of efficiently and effectively coordinate that becomes a challenge. So in the architectures nowadays, I refer to that, and I've heard people referring to that as everything that happens between React and Redux. So there's a lot of, there might be HTTP calls, there might be user interaction, there might be web worker communication, which I mentioned, WebSockets, and so on and so forth. There's a lot of things going on. That's a very complex topic, so I will try to give a rough overview. I'm going to throw a lot of different ideas and leave you with that to explore further. So what was the learning process for us? So that's not something that we've necessarily done, but I've seen it done, and I think it's a good idea. Because again, it depends on the context. If your application is simple enough, you can just embed your async calls in React components. Some people use Thunks, some people use Redux Saga, some people use Redux Observable. And we, again, a shameless plug, we eventually come up with something we call Redux Observable Lite. And probably there's more things that could be put on this list. So how would async calls in React components look like? Okay, so if the, so I have my interactive component. It's an input, and if I press, if I press on that input, it executes a call. It executes a handler. That handler calls some HTTP API, and from within the from within my handler, from within my React code, I just dispatch an action to Redux and inform of a output of that call. Simple enough. Possibly not very testable. Possibly can create to a very complex code, but if you just want to make something quickly, that works. And I'm sure there's at least 2-3 other ways to do that that are very simple and very good up until a certain point. So the next step, certainly next step for us, would have been thanks. So you're trying to decouple things a bit. You're trying to move the code. Separate the code out. So you move the action responsible for asynchronous call to a separate file, and that would look something like this. So you have, again, I have my component, and then I dispatch. Then I perform a dispatch, but instead of calling the API directly from the component, I dispatch something called thank, which is a asynchronous callback, and that thank performs the logic. So that logic is encapsulated into a block of code that can be moved to a separate place, managed separately. More separation is more organization on the design side. Then you might evolve to Redux Saga. Redux Saga can be a slightly tricky concept, so I will only kind of mention it quickly, and I certainly encourage you to explore this problem further. It's a great way as a step forward for some cases from thanks to organize your code in a more testable way. So instead of dispatching an asynchronous handler, you dispatch a plain Redux action. And then there's the smart framework code, smart library code called Saga that waits for the action. And on each action that arrives, it will execute a logic that's then responsible to call the API and produce an output action. So you can see how we basically implemented loose coupling. Loose coupling being there's no code, there's no compile level dependency. We communicate through a simple message here. And Redux Saga is certainly more loosely coupled, is more testable, it's more reactive. So I will come back to what reactive means in a second. Reactive is something that has been growing more and more popular as well in these days. Next, so what was our, before next step. So what was our discoveries when we compared thanks and Redux Saga? So thanks worked really well for us for quite a while. But testability wasn't great. Reactive aspects of it weren't great. And composability, as in nice design when you can connect things together, not that great. So for the at a certain scale, at a certain size of the project, we basically decided that we need those properties. So we, first of all, we knew the list of those properties. So we knew testability, reactivity, performance, simplicity, and composability are things that we, to different extent, might matter to us. And then we looked at these technologies and tried to kind of see, okay, which one satisfies which requirements. So we moved on to Redux Saga. Redux Saga was largely a good satisfying of requirements. Unfortunately, for our context, for our use case, performance wasn't that great at the time when we were using it, and so that's when we decided that we would like to try RxJS, which stands for reactive JS, which looks something like this. So you can see some similarity with Redux Saga. We have loose coupling. We just dispatch a Redux request action, and then we listen for that message to arrive, and then we perform the logic. And it has kind of, you know, nice, sort of becoming more popular, also like pipeable interface. Okay, so that's great. Again, I'm not going to be going too deep into what Redux Observable is and how it works. Again, I encourage you to look at further. But some examples what reactive means, because I've been talking a lot about this reactive thing, and reactive has been quite important for us when handling this number of events, this number of objects, and why it has been important. So reactive allows to express simple behaviors like process only one item every 100 milliseconds. So if you have thousands of items coming in at you, that might be a little overwhelming. So you need something in place for your application to be able to handle that load. And something that might be quite elaborate otherwise in RxJS, you would write it like this. Okay, get all my clicks. Click $, means stream of clicks. So that would be that sort of represents a pipe, an input, a pipe that kind of sends you clicks. So from that from that source, you keep sending clicks to that source, and that source keeps emitting them more down the line, downstream, and it throttles them. So it only processes one click every 100 milliseconds. Have I used MobX, and how does performance compare? I will come back to this question. That's actually very sorry, MobX. Let me have a think. I'm going to come back to this question. Now, another type of behaviors you would like to express: buffer items for 1 second, process them in a batch. So if you have, again, 100 items or thousands of items coming in, you might not want to process each one if the processing is sort of expensive, but you might package them in 1,000 and process them then. For example, if you want to make HTTP calls, you might not want to make 1,000 HTTP calls. You might want to package requests in a single in an array within 1 second, and then send one HTTP call with the buffered list of the items, and you would do it like this. This is an example for key presses, but you could imagine one for requests as well. And then you can also model a more advanced example. This is actually a real life example. I will not dwell on this, but do come back to this slide later or reach out to me if you're interested more. I will make a single attempt to try to explain that. If you have an expensive block of code, of asynchronous code, imagine something that does a for loop or does some complicated mathematics. You're sending a lot of events at it, and then you want to make sure that for each unique event, you only are processing one at a time, and at the same time, you always process the last one, so none of the arrived events get lost. You can model things like that really easily, and you model them like this. So I'm not going to dwell on this. Do reach out to me or have a read of that later. But kind of showing you that very complex requirements can be very easily packaged into a reactive programming into RxJS. Now, again, this is my subjective experience here, or our subjective experience in our project. We found that performance was good, reactivity was amazing. Unfortunately, there's two things that really lack in Redux Observable or in RxJS. Oh, sorry, I actually haven't explained that Redux Observable is a bridge between is a bridge between Redux and RxJS. So it's something that connects RxJS to Redux store. So I use these terms interchangeably, but it's that's what it is. Unfortunately, testability and simplicity suffered. So at that point in time, it was really important for us to move that direction because we needed that performance. Unfortunately, for a short period of time, it was really hard to test, and it was really not that simple. So onboarding new user, onboarding new people to the project, not easy if the library you're using is not easy, and also adding new features and understanding why something doesn't work. Not great if the framework using is not simple. So what we come up with is Redux Observable Lite, which I'm not going to focus on implementation, but I'm rather going to focus on the properties. So I'm going to go back to the bits about evolving your architecture, evolving your design. So something that my colleague said about RxJS, again, your mileage may vary. You had a problem, chose RxJS, now you have two problems. You probably heard that quote about other technologies as well. So we used a tool, or accidentally used this tool, applied explore, expand, extract. That's again from Kent Beck, which basically means at the beginning of your journey. So at the beginning of your journey, you can explore. So you can use tanks, you can use asynchronous calls directly from React, you can use whatever works. Then you move to a technology that actually satisfies might have shortcomings, but satisfies growth requirements. So as you grow your business, as you grow your application, you need to expand, you need to find something that's, might have shortcomings, but can scale. And at some point, you need to deal with those shortcomings as well. So for us, those were testability and simplicity, because at that point, you need to extract, which means you need to think about scalability of your onboarding new of your team, onboarding new people, being able to deliver business features in a manner that's not limited by some technology that you've chosen, and things like this. Strongly recommend this talk. Although he applies this to business and to product and to startups, I think it's very valuable for us technical folks to apply this to how we can learn, experiment, and fail, and learn from our failures in technology. So this is not a framework, what we created. It's implementation pattern, and it applies as an implementation pattern to your problems as much as other patterns. So one thing that was important for us: keep business logic out of the framework. I mentioned RxJS has 100 operators, so 100 of methods, and each method has very specific behavior. And every time you use it, you have to learn what it does, and it's very tricky. I spend a lot of the time on Gitter. Gitter is a type of a chat platform that some of the libraries use. So I spend lots of time asking people, hey, how does this operator work in this context? How does it combine with a different operator? It wasn't easy. So basically our solution here was, okay, it's a framework. Let's try to use as little framework as possible as we need, and model our business logic using plain old JavaScript. And basically, let's use 5 operators out of 100. Let's try to move as much. Let's try to avoid the temptation of using operators to model some of the business logic behaviors, and make it simpler at the cost of maybe discovering, where's the sweet spot? This way, we organize a handful of templates that address 99% of use cases. So basically, this is kind of following a Git philosophy. I really like applying Git philosophy in my design and in the architectures. It basically means that kind of like, so Git is a bit complex in itself, right? But once you learn it, you notice that Git has a number of simpler methods, like, set of simpler methods, 10 or 20 simple methods, like git checkout, git reset, git merge, and low level methods like git ref show, git ref parse, and so on. And the idea here is to separate your architecture, separate your design, so that it's easy to do 99% of the things that are easy, and it's difficult to do complex things. I think kind of keeping consistency and keeping symmetry is really important. Basically, it should be easy to do simple things, and it's okay to make things that are less common to be difficult. It's so much worse when it's around. When it's difficult to make simple things and easy to make complex things. And another thing that was very important for us, it actually fit Redux React philosophy. So what we did is we applied this pattern where you look at the existing metaphors, existing architecture that you have in your project, and you try to replicate it. So because people coming to our project would know how Redux and React works and how they work together, it would be then easier for them to explain to them, oh, okay, do you know what? When you use RxJS, it's actually analogous. You're actually following the same philosophy. So they wouldn't have to learn it second time, which has, some cost of having to build something custom, come up with it, do a bit of discovery, but in the long run, it really helps you support your project on a technical level. And again, our own subjective experience, we hope that we managed to get this sort of kind of silver bullet balance, where things are really important, really good when they matter for us, and they're pretty good where there's slightly less less important. So what did we learn with this whole journey in managing asynchronous calls? So you have all these acronyms: KISS, YAGNI, list, LRM stands for, all them stand for KISS, keep it simple, stupid, YAGNI, you ain't gonna need it, LRM, LRM for least responsible moment, but most importantly, something that nobody mentions, you will make many mistakes. Many technical projects try to avoid failure. I think what you often need to do is to embrace failure. And I'm not the first person to, I'm certainly not the first person to notice that. Many of you must have heard of a book called Anti-Fragile by Nassim Taleb. And I think that's what we sometimes less successful, sometimes more successful, try to do. And I think that's the right way in technical projects, especially as you start, try to kind of just embrace your long mistakes as well, not only day to day, not only sprint to sprint, but also half a year to half a year, and that's okay. Choose boring technology and then don't. I think again, kind of in the do you have a time? Yeah, let me come back to this question. There's a question on a chat. Let me come back to this a little later as well. So choose boring technology and then don't. I think, again, going back to the explore, expand, extract. It's okay when you're in the explore phase to choose something that's boring. And then you might, especially if you're noticing that the technical solution is becoming the essence or becoming important for the business as the distinguishing factor, it might be valuable to not choose the boring technology. It might be able to look into something, maybe more complicated, maybe that something that other people aren't using, because I think it's really important to choose something I really think choosing boring technology can be good advice. But also if you always choose boring technology and everybody's choosing boring technology, you will not have any competitive advantage over the others. So it's okay at the beginning, and basically, at some point you need to decide, what's your competitive advantage, what's your distinguishing factor. Simple doesn't mean easy. So kind of RxJS versus tanks. Tanks are really, but when you have 1,000 tanks in a project, your design isn't easy. RxJS isn't simple. When you have JS equivalent to 2,000 tanks as your design. So you need to kind of look at the high level picture of, okay, I have this really simple concept, but then as you multiply this concept, you're actually creating design that overall is more complicated than equivalent design using a complex that looks more complicated. That's why looking at going to a presentation and seeing all these snippets of code and people showing, hey, see, if you write this in this language or in this framework, it's really easy. That's not showing you much because you're seeing 50 lines of code. Really, like what matters is how that fits in 1,000 lines of code in a bigger project. Because when you compose things together, that's when it really shows its true face. So as an example is JavaScript. JavaScript is simpler than TypeScript, sure, but if you have a project that has 10,000, 100,000 lines of code, I would dare to say that TypeScript brings more benefits. And testability and simplicity can be ignored for a while, but not forever. I think that was important to mention to me because, many of us value testability and many of us value simplicity, and I personally stand by it. But I think there's also phases in the project where you potentially can sacrifice them. I think it's a bit dangerous. You have to consider your context as well. You might need to have a strong architect or a strong lead, or agree with your team about that. But if you want to go faster, you might want to consider that. That's what we did, and I think that's what we did successfully. We wouldn't be able to jump from one solution to the other if we haven't ignored testability and simplicity for a while. That's it, really. You've seen pictures of cats in the presentation. A friend suggested it. It's good if presentation has a few cats. This is Chai and Beaky, which is cats me and my partner have adopted a few months ago. So thank you, Chai and Beaky. And that's it, really. It's time for questions and comments. So go on and keep with the questions or comments coming, and I will start to try to answer what has arrived so far. So the first question: have I used MobX, and how does performance compare? How does performance of MobX compares to RxJS? I'm guessing. Redux. No, okay, no, haven't used MobX. There is another technology that we used or tried to use. Forgot the. forgot the name at the moment. There's an alternative RxJS technology. I suppose that wasn't part of the question. Yeah, as a short answer, haven't used MobX. How does performance compare to Redux? So I haven't really mentioned Redux that much. We actually have not had much problem with Redux per se. Redux is simple enough, or has been simple enough for us by itself. I think the most important consideration for us in terms of Redux was to use ImmutableJS. We have been recently looking at ImmerJS. ImmerJS is a very cool, interesting technology that allows you to use plain old JavaScript objects and ensure immutability. So check it out. But we haven't really had that much problem with Redux per se. I hope that answers the question. Do you have any time to overview how Redux RxJS solves this testability over Redux observable? Okay. Wow, that's almost a separate topic. So I think, let me think about it for a second. I think the biggest So Redux RxJS, or what as we call it, Redux Observable Lite as well internally, is really an implementation pattern. And I think the most important bit here that helps us with testability is moving the business logic, keeping the business logic out of our RxJS code. So when we first started using RxJS code, we got really excited, and we were using all these operators to implement behavior. That's where we ended up, asking around and being on chats and trying to understand how this operator works combined with that operator. And then we just noticed that testing RxJS in general is difficult. And so we try not to test, test RxJS. We try to write as few integration tests as possible and try to test business logic instead. So it's sort of like, the dad joke about a patient going to a doctor saying, if I move my hand, it hurts. And the doctor says, then don't move your hand. It's sort of this story. We try not to we try to use RxJS as little as possible, so we don't have to test it, because testing RxJS is still difficult. We try to keep the number of operators low. So I think we use maybe 5 to 8 operators out of 100, and we think really hard before using additional operators. And we try to use patterns so that most of the time your tests are easy because you're using a template, so you don't have to think about a new you don't have to think about new new sequence of RxJS functions, because you have already done it. So by trying to keep it predictable, by trying to keep the set of templates where you don't have to think, basically, try not, it's difficult to think about it, try not to think about it, try to make something that you've done already 10 times. And by keeping our business logic outside of RxJS. Sorry, a bit of a long question. I hope it helps. Did you consider switching to Cycle.js? So Cycle.js, not sure at the moment. We evaluated a few libraries. I think we evaluated Cycle.js, and we evaluated something else, which I can't remember at the moment. let me think. CycleJS, and there's one more library which I can't really remember at the moment, which is similar to RxJS. MostJS. There you go. So we looked at CycleJS. I think we looked at MostJS as well. I think the most of the considerations end with performance. Basically, it's very difficult to test performance in anger, like in a larger, in a kind of wider context. When I looked, so I don't want to. I don't want to, like. I'm actually not sure. I think we looked at it. I think the performance wasn't that great for our use case, and also the sort of integration with other tools was a consideration. It wasn't there. I think we looked more at MostJS than CycleJS. That what I believe looked more promising. Unfortunately, it's not as well maintained as RxJS. And you know, if you look, and that was quite important for us. Not sure which one you're using for styles. Does styled components have any performance overhead compared to less as CSS? Quick answer. That's not been a kind of using the same just to keep abusing the same vocabulary in a way. Our context does not include as much styling. So rendering is not, or styles are not a big part of our problem. So can't answer that question, unfortunately. I don't know. Where do you get the data from? Which API did you use? Did you recommend it? So some of it is proprietary. So I can't really elaborate much. Things that we did is we actually ended up building for historical data. We actually ended up building our own APIs for the need of it being really fast. Let me answer it this way. But it's definitely a problem getting the right API for your needs, and I think often you might end up where possible building your own API on top of whatever is available. What constraints led to choosing in-browser computation over, say, backend with socket communications? Business constraints. Basically business constraints. There's certain licensing and legal considerations in our domain which require us to put in that and not the other technology. So it was really out of it was really out of the question. So it was really all driven by the business. Is actually worker post message the only communication channel between threads? Possibly no. You might use local storage. So you might communicate through local, I believe you might be able to communicate through local storage. So local storage is sort of like a built-in database in your browser. Maybe cookies, I'm not sure. So basically those are like, you know, backdoor communication. The official communication is post message, but you could potentially think of different types of communication. I'm not sure about performance of these. And also just to the point of local storage, we have been using local storage, and it's sort of lands in the same area as Web Workers, as at least it did a few years ago when we used it and stopped using it. Actually, it's just very bare metal, and once you push it to the limit, there's a lot of kind of practical limitations that you hit against. So for so yeah, there might be if you create if you get creative, you can kind of figure out other communication channels. I believe these are the questions. Have you looked at using WebAssembly too? I'm very excited about. Very excited. I'm reasonably excited about WebAssembly. It's on our radar. It's on our radar. I'm trying to choose the right words here. I think we're in a hyper. I think we're in a hyper optimistic phase. I think we're in a hyper optimistic phase in terms of WebAssembly. I've seen a lot of. It's sort of like with Web Workers. I've seen a lot of examples of simple examples of WebAssembly. I've also seen a lot of examples saying, "Oh, look, it's 1,000 times faster." Now, my general rule of thumb is be very careful with micro benchmarks. I have not yet seen a blog post on WebAssembly that satisfied that sort of proved to me that it is like that was, you know, rigorous enough to show that it's faster. I'm certainly very excited about Rust to WebAssembly. And I'm certainly very excited about being able to have as bottlenecks of your application of things that are or by design slow in JavaScript, extracting them as programs and then building them as WebAssembly. So I'm certainly very excited about that. Rust seems, last time I looked at it, Rust seems to be still a bit immature in that space. So yeah, it's on our radar. I think it's still quite early. Very excited, especially about Rust to WebAssembly. Which small number, 5 to 8, RxJS operators? So I used to be a consultant, so I'm going to answer it in a consulting way, which is it depends. It will largely depend on your context, but we did certainly simple things like map, flat map, maybe group by, slightly more advanced, tap, buffer time, audit time, combine list with latest for advanced situations. I'm going to maybe a sensible list on and maybe an more elaborated answer on Meetup. But it's a good. It's a good question. I would definitely try to use the simplest as much as possible and be very careful about anything that sort of resembles business logic. Maybe two questions, and I'm not sure how much is coming. But let's maybe do 2 more questions. I do really enjoy answering questions, but just not to bore everybody out. Regarding backend API, being a person with Java background, do you feel backend is any better than Java Spring Boot server? Apologies if my question is out of context. It is a bit out of context. Let me this way. I don't think I'm the best person to question. I have not done in Java for a while now, so I'm not sure where Java is now. I certainly think that a lot of tooling, things like profiling, for example, profilers are so much better. And there's a bunch of IntelliJ. I'm a JetBrains user, so IntelliJ is so much Storm. I guess it depends, but then with JavaScript, you can use the same language in your whole shop, in your whole company. So it's probably a more complex question. Just waiting for any last questions. All right, I think that's pretty much it for today. Thank you so much. Thank you so much for your for being with me, and I hope you you found some things, at least a few things that that you found useful in the talk. And thank you much for hosting it.
Yeah, thanks very much, Pawel. Really enjoyed that. Really informative as well. So unfortunately, we haven't got anything booked in for next week just yet. If anyone is interested in speaking, who knows anyone who might be interested in speaking, please do get in touch. You can speak as an individual, as a representative, of your company. We're open to all kinds of talks. I'm sure you'll all agree these have been pretty good over the last few weeks, helping everyone stay in touch and hopefully put in some decent content out there. So yeah, hope you all stay safe, and anyone who is interested in giving a talk, please get in touch. See you all soon. Take care. Bye.